Lesson: Data bias and its impact on AI models. Data bias is a significant risk factor in AI model development, presenting challenges that can undermine the effectiveness and fairness of AI solutions. Understanding data bias and its impact on AI models is crucial for professionals aiming to excel in blockchain and AI risk management. This lesson will delve into actionable insights, practical tools, frameworks, and step-by-step applications to mitigate data bias effectively. Data bias occurs when the input data used to train AI models is skewed or unrepresentative of the broader context it is meant to address. This bias can manifest in several forms, including selection bias, confirmation bias, and representation bias, each contributing to flawed AI outcomes. For instance, if a facial recognition system is predominantly trained on images of individuals from a particular ethnic group, it may perform poorly for other ethnicities, leading to discriminatory practices. Such biases can have far-reaching consequences, particularly in critical areas like healthcare, criminal justice, and employment, where biased AI decisions can reinforce systemic inequalities. To tackle data bias, professionals must first recognize its sources and manifestations. A practical tool in this endeavor is the Data Quality Assessment Framework, which guides the evaluation of data sources for completeness, accuracy, and relevance. By systematically assessing the data, professionals can identify potential biases and take corrective measures early in the model development process. One actionable insight is implementing diverse data sampling techniques. This involves intentionally including a wide range of data points that reflect different demographics, behaviors, and scenarios. Tools like stratified sampling and synthetic data generation can help ensure that the training data is representative of the target population. Stratified sampling ensures that each subgroup within a dataset is appropriately represented, while synthetic data generation can fill gaps where real-world data is deficient. A critical aspect of addressing data bias is the use of bias detection and mitigation frameworks. One such framework is the Fairness, Accountability, and Transparency in Machine Learning framework, which provides guidelines for evaluating and reducing bias in AI systems. This framework encourages the use of fairness metrics, such as demographic parity and equalized odds, to quantify bias and assess model performance across different groups. The implementation of fairness-aware algorithms is another practical approach. These algorithms are designed to adjust the decision-making process to account for bias in the data. For example, reweighting techniques can assign different weights to data points based on their demographic attributes, ensuring that underrepresented groups receive adequate attention during model training. Similarly, adversarial debiasing techniques utilize adversarial networks to reduce bias by learning to distinguish and neutralize biased patterns in the data. Transparency and explainability are crucial in managing data bias. Professionals should leverage tools like the Interpret ML library, which provides interpretable machine learning models and visualizations. By understanding how models make decisions, stakeholders can identify biased behavior and take corrective actions. Explainable AI not only enhances trust, but also enables continuous monitoring and improvement of AI systems. Case studies provide valuable insights into the real-world application of these tools and frameworks. For instance, a study on a healthcare AI system revealed that initial models were biased towards predicting lower risk scores for certain minority groups due to historical underrepresentation in the data. By applying the FATML framework and reweighting techniques, the developers were able to improve model accuracy and fairness, demonstrating the effectiveness of these approaches in practice. In addition to technical solutions, fostering a culture of diversity and inclusion within AI development teams is essential. Diverse teams are more likely to recognize and address biases that homogeneous teams might overlook. Encouraging cross-disciplinary collaboration and incorporating perspectives from social scientists, ethicists, and domain experts can lead to more equitable AI solutions. Training programs and workshops on bias awareness and mitigation should be integral parts of professional development for AI practitioners. Continuous evaluation and iteration are paramount in managing data bias. AI models should be regularly tested against new data and scenarios to ensure they remain unbiased and effective over time. Feedback loops and performance audits can help identify emerging biases and guide iterative improvements. Moreover, maintaining open channels of communication with stakeholders and end users can provide valuable feedback and insights into potential bias issues. In conclusion, addressing data bias in AI models requires a multifaceted approach involving practical tools, frameworks, and actionable strategies. By implementing diverse data sampling, leveraging fairness-aware algorithms, and fostering transparency and inclusion, professionals can mitigate the adverse effects of data bias and develop AI systems that are both effective and equitable. Continuous evaluation and a commitment to diversity and fairness are essential components of responsible AI development, ensuring that AI solutions serve the broader interests of society without perpetuating existing biases.